This movie is for Unit 7, Learning Target 8, Solving Right Triangles. So when you hear solving right triangles, what that means is you need to find all the side lengths and all the angle measures. Now we've been looking at right triangles in this unit, and that's what we're going to be looking at to solve a right triangle. In order to solve a right triangle, we use trigonometry and the Pythagorean Theorem. Now, if we didn't have a right triangle, we could still solve it. And we would solve it by using two things, law of cosines and law of sines. Now, that is an extension and not something that we need to know in geometry. It is fun nonetheless. You will probably learn it at the end of your Algebra 2, or definitely you will learn it in pre-calculus. But for right now, we're going to look here at solving right triangles. Let's go to the first example. We see a triangle here. We've only got two things labeled. Well, actually three if we include this as our 90-degree angle. What I like to do is to identify, to solve all sides and all angles, I need to make sure I have all the side lengths. So I have side lengths A, B, and C. Oops. And I have angles A, angle B, and angle C. In order to say I've solved this triangle, I need to have all of these numbers here. Now remember, to label a side length, you label it with its opposite angle. So since angle A is here, side A is located down there. Since angle B is here, side B is located opposite angle B. And since angle C is here, side C is labeled C over there. And then obviously the angles are labeled. So this is our goal, to get all of the side lengths and all the angle measures. Let's write down our given. Our angle B is 38 degrees. Our angle C is 90 degrees. And the side length of B is 16. So our goal is to find the other angle. Let's find angle A. And right now, because of what's given, we could just do 90 plus 38, 90 plus 38 plus angle A equals 180. And I also know that A and B are complementary because those two angles need to add up to 90. So it's a quick 90 minus our angle B of 38, and we get 52. So angle A is 52 degrees. So I put degrees. Now, let's find the other two side lengths A and C. I already know what B is. Let's say I want to find angle A, or side A. In order to get side A, what I'm going to do is I'm going to stand at the angle of 38 degrees. Now, I could stand at angle A now that I found that to be 52, but what I like to do is always go back to the givens that I had so that I'm not using any of the measurements that I had to find. The reason for that is because if I've made a mistake in finding angle A, then I'm not using angle A to find other side length measures or angle measures. I don't want to build on a mistake that I create. So instead, I always go back to the given. I want to stand at the 38-degree angle. That labels 16 as the opposite side and angle A as my adjacent side. And I know that the tangent function uses those. So it's the tangent of 38 is equal to my opposite side of 16 over my adjacent side of A. We solve that by multiplying by A. It's in the denominator. We don't want that. We want to put it in the numerator to solve. Then I have to divide by tangent of 38. So A is going to be 16 divided by tangent of 38. So A is approximately 20.5. Now notice, I had to round that. I used trig. I got a rounded answer. And so I have a rounded side length value. When I solve for C, I don't want to use that value. So to solve for C, that's my hypotenuse. And I would use the sine function of my 38-degree angle because that uses my opposite side of 16 over my hypotenuse side of C. So then I would multiply by C on both sides. I get C times the sine of 38 equals 16, and then divide by sine of 38. C is 16 divided by the sine of 38. I type that in, and I get that C is 26.0. So now I have solved the triangle because I have found all of the side lengths and all of the angle measures. Let's go ahead and try another one. Let's look at this one. I've got side Z, side Y, side X. So over here, I'm going to label those. I need to find X, Y, and Z. I have to get angle X, angle Y, and angle Z. So what I'm going to do is look at my given. I've got 16 is X, so I'm going to plug that in. I've got 23 is my, that is not an angle measure. I meant to put that up here. 23 is my Y side length. And let's see, I've got Z is my 90-degree angle. So those are all of my givens. The next thing I want to do, I've got 2 of 3 sides, so I could just use Pythagorean Theorem and do 16 squared plus 23 squared equals Z squared. This will solve for Z. I get 785 equals Z squared. So it's really the square root of 785, which is approximately 28.0. So my Z side is 28.0. Now I have to get angle X and angle Y. So what I'm going to do is stand at angle X. No, I'm going to stand, let's stand at angle Y. We're going to stand at angle Y, and we're going to label the 2 side lengths here. This is my opposite side, and this is my adjacent side. So I know that I'm going to have to use the tangent function. So the tangent of Y is equal to my opposite side of 23 over my adjacent side of 16. And because I want to solve for an angle measure, I have to take out the tangent by doing the inverse operation. So my angle Y is the inverse tangent of 23 over 16. So Y is equal to, type that in, and we get 55.2. So I've got angle Y is 55.2. Now what I can do to get angle X is just do 90 minus 55.2, and that will give me angle X, which is going to be 34.8. I have solved the triangle because I have all my side lengths and all of my angle measures. That is all for this movie. Let me know if you have any questions. Thank you for watching.